Good evening, students. All of you are most welcome to today's class. Today I am going to talk about some chemical properties of metals and non-metals. Already I have discussed about the physical properties of metals and non-metals in my previous class. So today you come to the chemical properties of metal and non-metals. First of all, metals are electropositive in nature. Electropositive in nature. Whereas non-metals are electronegative in nature. Okay? First, metals are electropositive in nature, whereas non-metals are electronegative in nature. What does it mean? During the chemical combination of metals and non-metal, the atoms of the metal always release electron and form positive ion, whereas the atoms of the non-metal gain the electrons released by the atom of metals and form negative ions. Okay, and here what happened? During the chemical combination, the atoms of metal release electrons. Okay, release electron. Okay, and after the releasing electron, it becomes charged. So, it will form positive charge, or it is called positive ions. Okay, and similarly here, the atom, it will gain electron. Okay, it gain electrons, and after gaining the electrons, it becomes negatively charged, or you can say negative ions. Clear? So remember, during the chemical combination of metals and non-metals, the atoms of the metal release electron. It may be 1 electron, 2 electrons, or 3 electrons. Okay, the atoms of the metal release electrons and form positive ions, whereas the atoms of the non-metal gain electrons and form negative ions. Now, do you know what are ions? And there are so many basic things like this ions, symbol, formula, valency, acid, base, atomic number, mass number, gram atomic mass, gram molecular mass, isotope, isobar, allotropes, and these are actually some basic terms commonly used in chemistry. Okay. So, you can say that these are the alphabets of chemistry. If you do not know about these things, then definitely you will face difficulties in your higher study. Suppose if you don't know the alphabets, will you be able to write words and sentences? No, definitely not. So, may I request you to make a list of all the terms of whatever you have got in your lower classes. Okay, and you write the definitions, examples, and all the required informations in your personal copy. And definitely, I think it will help you in your future. Okay, now come to ions. What are ions? You can say this charged atom or group of atoms. Okay, this charged atom or group of atoms are called ions. Okay, in other words, you can say that atoms having positive or negative charge is called ion. Clear? The atom having positive or negative charge is called ions. Okay, and similarly, a group of atoms having positive or negative charge are called ions. Okay, as for example, after releasing one electron by the sodium atom, then sodium atom will be positively charged and it is called sodium ion. And similarly, after gaining one electron, chlorine will be negatively charged. Okay, then you can say it is chloride ion. Okay, and sometimes, okay, a group of atoms behaves like single unit. Okay, sometimes a group of atoms behaves like single unit, and such group of atoms having positive or negative charge are also called ions. As for example, OH. Okay, OH, and it is also group of atoms. There are two different types of atom: the atom of hydrogen and atom of oxygen. Okay, although there are two different types of atoms, but together they behave like a single unit. Okay, so the group of atoms having charge is also called ion. Okay, and similarly, then this is carbonate ions. Okay, similarly this is carbonate ion, and similarly again this is ammonium ions. Okay, although there are different atoms together, but they behave like single unit. Okay, clear? I think it is clear to all of you. Okay, so once again you remember that the charged atom or charged group of atoms are called ions. Okay, and here one more thing. As there are more than one atom, okay, so they are known as polyatomic ions. Poly means many. As there are more than one atom, okay, so they are known as polyatomic ions, and this is known as hydroxyl ions or hydroxide, and this is known as carbonate ion, and this is known as ammonium ion. Okay, then here one question is arised: why does the atom of metal release electrons, and why does the atom of non-metal gain electron during chemical combination? Okay, now let us discuss about that. And before that, you should know another thing. Why does sometimes the transfer of electrons between the atoms of metal and non-metal and sharing of electrons between the atoms of non-metal takes place? Why? Okay, already I mentioned in my previous class that except few atoms, that is atom of the inert gases, all other atoms are unstable. Okay, so they combine with each other. Means one atom combine with another atom of same element or other elements in order to get the stability. So you remember this point. Okay, the atoms of same element or different elements combine in order to get the stability. How does atom will acquire stability? If the atom acquires 8 electrons in its outermost orbit, then it will get the stability. Okay, so you should know what is outermost orbit. So let me talk about these things. And so once again we have to go back to atoms. So we should know something about the structure of atoms. I think all of you know about our solar system. In our solar system, there is what? There is sun at the center. Okay, similarly, in an atom, there is nucleus. There is nucleus at the center of the atom. Okay, and in nucleus there are two different types of particles. These are known as subatomic particles. They are proton and neutrons. Okay, in the nucleus of the atom there are two different types of particles. They are proton and neutrons. Clear? Okay. And here you see, surrounding the sun, all the planets and satellites are revolving at different orbits. Am I right? Surrounding the sun and planets and satellites are revolving at different orbits. Do you know why the planets and satellites are revolving around the sun? You see, there is a force of attraction in between any two objects of the universe, and this force of attraction is known as universal gravitational force. And here also there is a force of attraction in between the planets and the sun, but the amount of force and the mass of sun is more as compared to any other planets or satellite. Okay, so the satellites and planets unable to pull the sun towards them. Okay, instead of pulling sun towards them, and they are moving around the sun due to the attraction force of sun. Okay, to get the clear concept, simply you think this way. If you go up to a certain height, okay, then again you will fall back to the surface of earth. Okay, but if you go up and up, if you go on this way and at a certain height, no doubt you will feel the force, or you will experience the force due to Earth's gravity, but that amount of force will unable to pull you to the surface of Earth. Okay, and these satellites are also launched on the basis of this concept. And you know that the moon is revolving around the Earth. Why? Because there is a force of attraction in between moon and the Earth. Okay, but the distance between moon and Earth is such that the attraction force of Earth unable to pull the moon to the Earth's surface. Okay, but at the definite height, moon experiences force due to Earth's gravitational pull. That is why the moon cannot escape this gravitational field. Okay, Earth gravitational field. The moon is within the Earth gravitational field. Okay, and here the attraction force of Earth acts as a centrifugal force to move the moon surrounding Earth. Okay, is it clear? And here, in case of atom, surrounding the nucleus, electrons, they are also one type of subatomic particle. The electrons are revolving at different orbits. Okay, it is almost similar to the solar system. In our solar system, there is sun at the center. In case of atom, there is nucleus at the center. Okay, and in solar system, the planets are revolving around the sun at different orbits. And similarly, in case of atom, the electrons are revolving around the nucleus at different orbits or different energy level. Okay, and as I mentioned that there are force of attraction in between these heavenly bodies and sun, due to which the heavenly bodies are moving surrounding the sun. And similarly here, there is a force of attraction in between the nucleus, okay, and the electrons. And due to this force of attraction, the electrons moves surrounding the nucleus at different energy level. Okay? And here one more thing you have to remember, that definite number of electrons can be accommodated in different orbits. Definite number of electrons can be accommodated in different orbits. As for example, in the first orbit, there will be 2 electrons, and in the second orbit, there will be 8 electrons. Okay, that means the number of electrons at different orbits of an atom vary. Okay, it is not same, and it is different from atom to atoms also. Clear? But you remember, in any atom, in the first orbit, only 2 electrons can be accommodated, and in the second orbit, only 8 electrons can be accommodated, and so on. Okay? Clear? Now, again, you should know the characteristics of these subatomic particles. Already we have got that there are 3 subatomic particles, that is electron, okay, then protons, and then neutrons. Okay, these 3 are the subatomic particles. And here electrons are negatively charged, protons are positively charged, and neutrons are neutral. Okay, and one more thing, as compared to the mass of proton, the mass of electron is negligible. Okay, and the protons are present in the nucleus. So we can say that the mass of the atom is concentrated at the nucleus of the atom. Okay, clear? Now again come back to our original question, that why do atoms of metals release electrons and atoms of non-metals gain electrons? And to understand that things, and we should take some examples. Okay, let me take examples. I am going to take one example of metal atom and one example of non-metal atom. Say metal sodium. Do you know its atomic number? Atomic number means number of protons present in the nucleus of the atom. Okay, and you have to remember the atomic number of all the commonly used elements. Okay, and here you remember that the atomic number of sodium is 11. Okay, it means that the number of protons present in the nucleus of sodium atom is 11. So there are how many protons? There are 11 protons. Okay, and another important point, in a normal atom, the number of protons is always equal to the number of electrons. Okay, so in a sodium atom there are 11 protons and 11 electrons. Okay, now let's see the arrangement of electrons surrounding the nucleus of this sodium atom. Okay, and say this is the nucleus of sodium atom. There are how many protons? There are 11 protons. And for the timing, you forget about the neutrons. Okay, now there are how many electrons? There are 11 electrons, and only 2 electrons can be accommodated in the first orbit. Then in second orbit there are how many electrons? And there are 8 electrons. Okay, in the second orbit there are 8 electrons. Then how many electrons left? Only 1, and it will be in the third orbit. Okay, clear? And another important point here you remember, in order to get stability, atom has to acquire 8 electrons in its outermost orbit. The last orbit is called outermost orbit or valence shell. Clear? The last orbit of an atom is called its outermost orbit or valence shell. Okay? And here, how many orbits? 1, 2, 3. So the third orbit is the last orbit, or you can say this is the outermost orbit or valence shell. And the electrons present in the outermost orbit are known as valence electrons. Okay? Then here, now you see, sodium has only one electron in its outermost orbit. And already I mentioned that if the particular atom acquires 8 electrons in its outermost orbit, then it will get the stability. Here, in order to get the stability, either sodium has to gain 7 electrons, okay, or it has to release 1 electron. And if it is able to release 1 electron, then third orbit it won't be available here. And then the second orbit will be the outermost orbit having 8 electrons. Then it will get the stability. Okay? Then once again come to this non-metal example. Say chlorine. And the atomic number of chlorine is 17. So there are 17 protons. Okay? That is why there are 17 electrons. Clear? Okay, now we see the arrangement of the electrons surrounding the nucleus. And here 17 protons. Okay? Now in the first orbit there are 2 electrons. In the second orbit there are 8 electrons. Okay? In the third orbit, there are how many electrons then? 2 plus 8, 10. Then 7 electrons left. So, definitely, they are in the third orbit. So, 1, 2, 3, 4, 5, 6, 7. Okay. Now, in case of atom of chlorine, it needs only 1 electron. To get the stability. And here also, either it has to gain 1 electron or it has to release 7 electrons. Clear? Now you come to another point. Already I mentioned that electrons are negatively charged, protons are positively charged. Okay, and due to this attraction force in between this proton and electrons, the electrons are revolving surrounding the nucleus. Okay, here number of protons 11, and here number of protons 17. So the total amount of positive charge in the nucleus of sodium atom is lesser than the total amount of positive charge in the nucleus of chlorine atom. Okay? So, whenever both the atom will come close to each other, this electron will be pulled towards the chlorine atom because the attraction force of this nucleus is more than the attraction force of nucleus of the sodium. Okay? To get a clear concept, you take another example. Say this is a particular object. Okay. Two forces are applied from opposite direction. Now, two forces are applied from opposite direction. If the amount of forces from both the direction remains same, the object will not move to any direction. Okay? If the amount of force in a particular direction is more then definitely the object will move towards that direction. Means towards the direction of net force. Okay? And here suppose amount of force is 1 Newton towards this direction. And again here also amount of force is 1 Newton towards this direction. So there is no net force to act it in a particular direction. That is why the object will not move from this particular position. Okay, but if the amount of force in this direction is more than its opposite direction, and definitely the object will move towards this direction. Okay, and here also you compare this with this example. Here the amount of force is more and here the amount of force is less. So the electrons, definitely it will move towards the direction of greater force. Am I right? Okay, and in other words you can say that the nucleus of the sodium atom does not have enough energy to hold 8 electrons in its outermost orbit. Whereas the nucleus of the chlorine atom has sufficient energy to hold 8 electrons in its outermost orbit. Okay? Due to this particular reason, at the time of chemical combination, the atoms of metal release electrons and the atoms of non-metal gain electrons. Okay, and another important point you remember, there are either 1 or 2 or 3 electrons in the outermost orbit of atoms of metal. Could you follow the point? In case of atoms of metal, the number of valence electrons may be 1 or 2 or 3. But in case of non-metal, the number of valence electrons means electrons present in outermost orbit. The number of valence electrons is either 4 or more. Okay? Then you see, the atoms of non-metal having same number of orbits have more number of protons. And here atoms of the metal having same number of orbits has less number of protons as compared to the atom of non-metal. And as per example, here you see number of orbits 3, 1, 2, 3, and here also number of orbits 1, 2, 3. But the number of proton is more here than the nucleus of sodium. Okay? And always it will happen because in case of non-metal, always the number of valence electron is more than the number of valence electrons in the atom of metal. Okay? Clear? Okay. Then I think it is clear to all of you that why does atoms of metal release electron and why does atom of non-metal gain electron. I think this is clear. Then again another question is arise. Why is metal atom positively charged? And why does an atom of non-metal negatively charged? And here you see once again, in a normal atom, number of proton is equal to number of electrons. Okay? in a normal atom, number of proton is always equal to the number of electrons. And amount of charge of a proton always equal to the amount of charge of an electron. Okay, that is 1.6 into 10 to the power minus 19 coulomb. Coulomb is the unit of charge. Okay, now I see. In any normal atom, it may be atom of metal or non-metal, the number of proton is always equal to the number of electron. And again, the amount of charge of a proton is always equal to the amount of charge of an electron. But they are oppositely charged. Protons are positively charged and electrons are negatively charged. Okay. Suppose you think about the sodium atom. When sodium atom releases one electron, then number of proton, it will remain same. Okay. Then number of electrons, it become 10. Okay. Number of protons, it will remain same as 11, but whenever the sodium atom will release one electron, means whenever it will donate one electron, then total number of electron will be 10. So total amount of positive charge will be more than the total amount of negative charge. Okay, then there will be a net positive charge. So after releasing electron, the atoms of the metal will be positively charged because their total positive charge will be more than the total negative charge. Okay, clear? Suppose you see, just you think about this. Suppose you have 10 rupees. Okay, and you have to give 10 rupees to someone. You have to give 10 rupees to someone. Okay, then how much amount of money will be left in your hand? No, nothing. Okay, and again, if you are taking, say, 1 rupee, then you have to give 11 rupees. But you have only 10 rupees. Okay, so again you will remain as a borrower because still you have to pay 1 more rupees. Okay, this case is same as that of proton and electrons. Okay, I think this is clear to all of you. Why does the atoms of the metal become positively charged after releasing electron? And why does the atoms of the non-metal becomes negatively charged after gaining electron? And one more thing I forgot to tell you, that the positive ions are known as cation. You remember this, huh? And the negative ions are known as anions. The positive ions are called cations and negative ions are called anions. Okay, clear? And I think this first characteristics of metal and non-metal is clear to all of you. Then what is that? Metals are electropositive in nature and non-metals are electronegative in nature. Okay, and the fact is already discussed to all of you. Okay, I think all of you have got the clear concept. Then in the next class again I will discuss about the remaining characteristics of metals and non-metals. Okay, Till then, take care. Okay, bye bye.